Owen Astrachan is the Director of Undergraduate Studies in Computer Science and Professor of the Practice at Duke, where he has taught in 4 decades and 2 millennia. In addition to teaching computer science, he builds curricula and approaches to teaching intended for broad adoption and adaptation. Professor Astrachan received an NSF Career Award for introducing design patterns into undergraduate courses, was an inaugural recipient of the NSF SICE Distinguished Education Fellow Award for emphasizing problem-oriented approaches, and is the PI of the current NSF College Board CS Principles Project. In 1995, he received Duke's Robert B. Cox Distinguished Teaching in Science Award. In 1998, he received the Outstanding Instructor Award, and in 2002, he received Duke's Richard K. Loveland Award. Owen enjoys thinking, running, collaborating, and pushing limits gently. Thank you.
This is me. I'm giving you my Gmail address, and interestingly, Fred asked me why I put that there instead of my Duke address, because you can, in a pretty quick Google query, you will find all my Duke addresses. But this is the one that if you want to share a document with me, for example, in Google Docs, I prefer you to use that. And this presentation right now that I'm giving, assuming the internet holds up, is done via a presentation in Google Docs, and you can get to it that way. So I've shared it with you there in case you want to look along now or look along later, and I'll make sure. I think CSTA has that. I need to understand a few things. So how many of you have been a student? Just check. How many of you teach an Exploring Computer Science-like course in high school? How many of you teach a Computer Science Principles-like course in high school? How many of you teach a Computer Science A-like course? How many people don't teach in high school? All right. Well, so my goal today is to kind of look at search. Oh yeah, search. Yeah. Okay. Here we go. Our species needs and deserves a citizenry with minds wide awake and a basic understanding of how the world works. Awake, even though it's just after lunch. People were out late, maybe. So I'm going to try to make sure that you can't fall asleep, and I'm going to involve you with what's going on. So the first thing I'm going to do, I'm telling you that I'm going to try to do this in a way that if I was teaching a course, I would try to teach some of the things these ways. So the first thing you're going to do is we're going to define what is computer science, and you're going to write your own definition. You need to do this, and if you refuse, that's fine. You can think about it yourself. What you're going to need to do is write down like maybe 2 or 3 sentences so that you have, this is my definition of computer science. Not the definition that you think someone else is going to write. This is your own definition of computer science. And I'm going to give you a couple of minutes, and then you're going to get together with an elbow partner, somebody else, and you're going to read each other your definition. And time permitting, I'm going to have to compress this in a way I'll discuss later. If you can, this is a place where you can enter your combined definition in a Google form that we could then share out among this group. So there's 3 steps that you have to do, and of course, you'll fail the course if you don't do them. Write your own definition of what is computer science. I'm going to give you a couple minutes, then I'm going to go bing, 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 and I want you to share it by either giving it to your partner or reading it with them. And then maybe you can combine that in another 2 minutes and enter it on that form if you have time. I'll explain later how I'm condensing like 4 hours of stuff into 50 minutes to leave time for questions. Tick-tock, though. What is computer science? You're going to get to refine this definition 16 times during the year, so you don't have to nail it the first time. And in the interest of getting through everything, you should find yourself a partner. Share your definitions with them. Read yours. Have them or her or it read his.
Well, I
If you have time, if you go to that website, if you have time in an electronic device, you can enter online.
I have this
seriously simple.
Okay, so.
Computer science is creating executable
Okay, you have 1 minute to finish, and if you're not finished, you have to say you're done.
Why do you copy and paste everything in there?
Right here, just right here. Right here.
I thought
Where is it? I don't see it.
Oh, and are we on step 2? Are we supposed to be refining?
We're going to be done with all these steps in about 30 seconds. If you haven't gotten there, that's okay. You can continue to work after I start talking, as long as you do that with your quiet voices. And what we're going to be doing, and I'll explain the details of how I'm trying to do this, but if you came up with a common definition, that's fabulous. If you've been talking about this the whole time, that's fabulous. In a longer period of time, we get to the point where you would all enter your common definition in that Google form, and then what would happen is you would see the results. So if you go to this form, that link, you could see all the common definitions that you've gone into. And we would make some wordles out of it, or we would discuss some other similarities. We take some time to go over this computer science so that we can kind of understand what it is you think computer science is, so that you could use this activity in different ways if you were giving a workshop to teachers, than if you're giving a workshop, if you're using it in your class and understand from your kids' point of view what's going on. So I'm condensing this all down, but I want to make sure that you understand this is how our students find the answer to what is computer science. If you ask them, they might do this. So this is not how I normally do it. What's the difference between how I normally do it and what I've put up here? One-word answer. Google. Right. So, but I want to make sure have not sold my soul completely to Google. This is how you search in some ways using Bing for what is computer science, and I'll come back to it in a minute, but this is the result that you get. I took a screenshot. That's the result I got. So clearly, what kind of search was I doing? Image. I was doing an image search. So this is what happens when you use Bing to do an image search, and there's some clues in there when you look at it. That's an image search, like maybe that clue. And if you look at the queries for both Bing and Google, so these are the side by side. If you do an image search in Bing and an image search in Google for what is computer science, and the results are strikingly similar, but not the same. So they share some images in common, but not all. And if we were taking more time as a group, I'd ask you to come up with what's similar between both of these URLs. These are both URLs. So what are some things that have in common?
Query statement at the beginning.
Yeah. They have a query statement? You think that's this Q equals thing?
Yes.
Okay, they both have that? What else do they have besides that query string?
Search.
They have the word search. Search question mark.
Plus is separating.
The pluses, and we know what, now, some of you may know what those pluses are. What are they? Space. So that's how the URL encodes the space, because I didn't type in plus, I typed in what space is space, computer space science. And then there's some other stuff in there, and some of you know, and some of you could guess. You know, what are these ampersands separating?
Separate items in the, I know they're called.
Search
separate
criteria.
parts of-
Search
Attributes.
actions, search
Filters?
filters, search
Variables.
variables, parameters, maybe? Variables, parameters, those are all kind of the same thing. So this is search, and it's interesting that all that stuff is encoded in the query that goes to your search engine. It takes that stuff and gives you all the stuff back. And that, I'm going to come back to that idea several times, but you could have lots of questions about what's the role of ampersand, what's the role of the question mark, how do you even write what is the role of the question mark without two question marks? That's a little tricky. And we saw some differences between the two. And then if we had more time, I would ask you to all come up with a question that you had related to these URLs, and we'd go back and forth on it, but we're doing the condensed version of this search because I hope I'm in the right order. Well, here's what I want to do. So that was the introduction. You did computer science. We looked to see what some of the search engines thought about it. So I'm going to look at three kinds of search, and I'm going to try to model a little bit how you could do them in your classroom in ways that I would also have done them in my classroom, although I'm teaching at Duke right now. I'm not teaching in the high school, but I think all these things could be done in high school. And one time long ago, I was a high school teacher. We're going to engage in these activities and these discussions, but this is kind of the Julia Child school of how things work. Now, some of you were old enough to know who Julia Child is. Some of you saw Julia and Julia, the movie that's about Julia Child. But here's what happened. I was kind of forced to watch Julia Child on one of the 3 channels when I was growing up. And here's a picture of Julia Child, and she was the French chef. And she had this voice. She kind of talked in a funny way. And she would start cooking at the beginning of a 20-minute show, or maybe 25-minute show. She said, "We're going to bake turkey!" And then she'd do it all up. And then she'd put it in the oven. And then she said, "I wonder how it's going to taste." And then she'd open the oven and the turkey was done. So she kind of condensed the whole cooking process in this time so you could kind of see some of the prep but get the result at the end. So that's a little bit about what I'm doing here because we have a very limited time. So I hope to give you a flavor for how you could use these activities, but if you're actually going to use them, you'll probably have to expand them a little more because I want to have enough time to get the taste and be able to come back. And some seasoning, yes, exactly. So I have 3 courses. I have CS Principles, Exploring Computer Science, APCSA, and I'm going to try to take a look at 3 different ways of search that you could do in each one of these. But now, since I have experts in the room, I'm going to call on you instead of telling you just my point of view. And here's the searches, and this is kind of a diagram of what I'm going to do. So I'm going to do a quick tour through binary search. I have a pretty good idea of how I could use these in all those courses. And in fact, they're required in all those courses. You must talk about binary search in all of those. I'm going to talk about content ID. I'm going to take a little bit heavier view from computer science principles, but I'll tell you how you can cut them there. And then PageRank, and I think it's more in this area and a little less there. It just means I haven't quite figured that one out. But I'm going to try to give you a flavor for all of these searches and how you could do them differently in all those courses. So here's a video that I'm going to start with binary search. And if you've never seen this, okay, I hope that it is visible and audible.
193.
Higher.
540.
Higher.
820.
Lower.
700.
Higher.
749.
I'm going to have to sit down and regain my composure after that. I hope realize we are in the presence of a miracle. The clock was...
Okay. Hold on a second. No, Bob Barker said, I'm going to have to sit down. It's a miracle. These are the guesses that the woman gave. Okay? So I want you to talk for 30 seconds with someone next to you or in front of you or behind you. Are these reasonable guesses for what you saw?
What's the sickest?
Oh yeah, discuss. But because this is the beauty of an online thing, I think you meant discuss. And I don't even have to resave it. There's no save button. All right. So talk with somebody for 30 seconds. Are these reasonable? Go. TikTok. Time's up! Did you decide? Who decided? No. If you have to be yes or no, they're reasonable or they're unreasonable and it was just miraculous. Are these reasonable? Yes. It's a miracle. I'll give you the summary of conversations I've had when I've done this in the past. And the key one that people often hone in on is once you get to here between 800 and 700, at that point, oh yeah, prices end in 9. It's not unusual. That's not way out of whack from here to there. And going up there, it's like they're arbitrary, but they're not. It's not like 193, 194, 195. So you could have a discussion, and if you could do this in a more drawn out way, you could get your students to kind of participate doing this. Most of you have probably done the guess a number between 1 and 1,024, and if you ask your students, I'm going to tell you high, low, or correct, what's a good first guess, and you all get 5 seconds to come up with one, and then you're going to shout it out. Now, when I do 1,024, that's harder. I usually do it 1 to 1,000, and then the students all get it right. But if I say 1 to 1,024, it's like, oh man, I don't know. 5. You might not get all the same. But you know, I hope that you all know, and only I think once in kind of 25 years did I get like somebody just convinced that 1 was just as good as 512 because they both had an equally likely chance of being right, and you might as well just do it that way. And that was, I knew I was going to have some trouble with that student. But we'll get them up to speed. There's, in exploring computer science, there's this tower game that some of you have done. You know about that. That's for binary search. It's explicitly in the curriculum. How you lead up to that is kind of up to you. This is how I try to introduce binary search in the 2 different classes. I teach one of which is like our version of APCSA, our intro course. I'll get to that in a minute. And the other one is Computer Science Principles, where we're trying to get at these kind of concepts about how many guesses to guess a number between 1 and 1,000,000 using binary search. About 20. That's a miracle. That's the miracle of logarithms. And you can kind of get this idea across. It's not that many. You can have a picture of binary search that kind of illustrates what's going on, because some people have visualizations or make more sense. You know, with 1 guess, I eliminate half the numbers, and you can kind of show that this is going on. In my interlude, I'm going to now lead into what I do in our intro course, which is like APCSA. So I'm not going to go to this link right now. Instead, I'm going to discuss the results of that link, which are an overflow of love and emotion. And I'm going to do that by giving you a program. I'm going to give you in a minute a multiple choice test on this program. So I'll give you that 10 seconds to look at it. This is a Java program. It's syntactically legal. I'm going to actually run it in my Java environment in a minute. And I'm going to ask you to tell me what happens when I run it. So I have another version with my choices on it. You probably can't read that one as much. Can you read that in the back? Some of you. Right, you have 4 choices. 1, it runs forever. 2, it runs until memory is exhausted, which is about 4 minutes on my 8 gigabyte machine. It runs for about a second and it prints 2 billion, about 2 billion. Or it runs for a second and it prints about negative 2 billion. So you're going to have to make a stand, A, B, C, D. And we're not going to do this as a group activity, which normally I would do, and we'd get together and we'd discuss it. So you're just going to do the kind of, you're going to hold up like 1, A, B, C, D, and I've learned this technique of holding it here so that other people don't see it, because if you just say, who many says A? And all of a sudden everybody's looking around like, oh yeah, I do. So you have 1 finger for A, 2 fingers for B, 3 fingers for C, 4 fingers for D, and there's no reason, don't worry about getting it wrong, okay? Right, so a 1, 2, 3, 4, go. Well, it's cool if you look around the room, every single number is on someone's chest, every single one. Which makes this a good discussion question, because then you can do something like I'm about to do, which is run it. It printed, it ran, let me get rid of that sign. It ran and it printed the value of X is about 2 billion. Now, because this isn't a lesson on overflow on why that happened, I'm not going to go over it. If you have a question at the end, I'll be happy to answer why that happened. As you're looking at it, you might say, oh yeah, X is always less than X plus 1, except when it's not. And when it's not, apparently, at about 2 billion, 2 billion plus 1 is, and it turns out that it's negative 2 billion because of overflow. Infinity plus 1 is minus infinity. We can have a whole thing on this. Now we've got to it in kind of a discovery way. And that's what's going to lead me to, in the new APCSA, this is new this year, they give you an implementation of binary search and you're required to know it. It used to be that you had to know the concept of binary search. But now in the book, they give you this exact code. I copied and pasted this from the new course description for APCSA, and you must understand this code. And I'm asking you to tell me, what line of this code is buggy? This is copied and pasted from the book. Now, that's probably unfair, because let me tell you, when this code is pretty much like the code that's in java.arrays.binary search, which was also buggy for 10 years. And it was buggy until they had so much memory that all of a sudden there was an array with 2 billion elements. And when there got to be an array with 2 billion elements, this code failed. And remember, I kind of was trying to seed the discussion.
When you add left and right together, it could overflow.
You add left and right together, it could overflow. If right's about 2 billion and left is about 1.5 billion, you add 2 billion and 1.5 billion, and you don't get, as we just saw, 3, you get like negative something. So that line will result in integer overflow. And you can replace that line with the algebraically equivalent, and I'm going to say this, I'm going to say algebra. Left plus right minus left over 2. And if you do the math on that, common denominator, right minus left. Left plus right minus left over 2. Well, guess what happens with right minus left? There's no overflow. Now, is that important?
Only in certain circumstances.
I'll tell you what, it turns out in APCSA, you're supposed to know about integer overflow. Does knowing that bug make a difference? I mean, if you're implementing Java, it does. Is it okay in this case that this code could have been, like, if a student saw left plus right minus left over 2, they might go, I don't have any idea what's going on there. Why is that there? So showing that's probably not a good idea. But this is not a discussion, what we just had, that I would have in my computer science principles lab course. Because I would start losing people the second I started doing that algebra thing, even though I think it's kind of important to understand in some way. So you have to kind of guide and figure out where do you want to do things and where do you want to not do them, and figure them out. So I just did 3 views of binary search. I wanted to construct an understanding via an activity, a game. That's what's done in Exploring Computer Science with the Tower game. Many of the things in there are done in a constructive and inquiry-based way. It's part of the course. In Computer Science Principles, I would hope that a student in my course would say, if I tell you it takes 20 guesses for 1,000,000, how many for 1,000,000,000? I would want them to be able to figure out that when you kind of multiply by 1,000, it's log of that the factor goes up. And in Computer Science A, maybe you'd say, how many times is that statement executed when elements.length is 1,000,000, because now I have to know that source code. So it's 3 different ways of looking at that one thing. I'm done with binary search. I'll leave time at the end for questions. Lyrics. Those are lyrics. Anybody know that song? Yo, Jeff Sullivan. What song is that?
Don't know much about, it's
Don't know much.
don't know much about
But I do know. I love you, and what else? Math. 1 and 1 is 2.
Oh yeah, that's right.
Dude, what a wonderful world it could be. So, if I apparently you all kind of know that song, and have you heard up here? It is by Sam Cooke. Most people don't remember that, or never knew it, or had to look it up. But does anybody have a phone, a smartphone that has Shazam or SoundHound on it?
Yes.
That you could run right now? So I have a song. Now, if you already know this song itself, you're not allowed to say. But if you don't know it, we're going to find out in a minute because we're going to SoundHound it. You got it already? I believe we just heard it was many rivers to cross before we even got to the lyric. And just for the record, your phone listened to that, giving you some anthropomorphic qualities, did something, sent it over the internet. It's not like your phone knows that, right? It went over the internet in this room that's equipped with internet.
Sort of.
Well, we got the answer! And then it came back, and then it said, do you want to buy the song?
Yes.
It said, would you like to buy the song? So now that's a miracle. Forget the guessing number thing. That process, that's kind of interesting, at least to me. And at least it turns out that most of my students think this kind of song thing is kind of intriguing too.
Your timing was almost looked like it was rehearsed between the two of you.
Did we rehearse this?
No.
No. And the other thing with, well, we'll get to what's interesting about SoundHound. In doing my Julia Child thing, I'll give you a little bit of view, but when you upload a video to YouTube, that video and the audio are scanned by the YouTube Content ID scanner people. It's not a people, it's an algorithm and a program. And then something happens to you. So I'm going to just kind of cut out of this to this page. Hold on a minute. I have these videos queued up just to show you a little bit of difference. So here's one of them. This is one of those. You may have heard this song.
What is love? Baby, don't hurt me. Don't hurt me.
Okay. 19 million views. And buy What is Love. So there's a link to buy it, right? Okay, check. Here's the other one. cutting ahead because this is a linebacker on the Duke football team. Taking my course, they have to do is create a video and put a song to it and upload it to YouTube. That's what happens when they make a program work. The audio quality is not so good there, but he wasn't singing, obviously he was lip syncing, in case you didn't know. Buy What Is Love on YouTube. Same link there. Did YouTube take this down? No. They slapped an ad on it. Is it possible, depending on who the artist is, when you upload that YouTube will take it down? Yes. Does anybody know an artist that's notorious for saying no? Prince. Yeah. You put a Prince song up there, and invariably it's coming down right away. Even, and so these are all the videos from my class where you have to make a video with some educational content. So this is one about what's in the payload of an internet packet. And it's a PowerPoint presentation, and you have to put a song behind it. The goal being that when you upload it to YouTube, it will be taken down. And then you can write them and say, I believe that with fair use that this has an educational content. And I'm not actually taken away from the sales of this song, and I look at the 4 prongs of fair use, and I want you to put it back there, you two people. So we have that discussion because...
Did they do it?
Yeah, although it turns out that it was easier to do this assignment like 4 years ago when YouTube was taking everything down. Now, most artists just want to monetize. So if you put it up, they're happy to say, yeah, you can have it here, slap an ad on it. Or slap a buy here. So it's rare that you get it taken down. And because most of these things are now so automated rather than being taken down by request, it used to be that the copyright holder would request YouTube to take it down. Now they're just automatically there. The content ID scans it, automatically takes it down because they have an agreement. So it takes a lot longer to get it put back. 3 years ago, we got some put back. And lately, the students kind of have given up on the assignment before it gets there. Not giving up on hoping it gets taken down. They're happy to make the educational thing and upload it, but then following through with everything. So here's what it says on YouTube. Getting to this one, it says, 25 million reference files are in the database. They scan 400 years of video every day. To scan that to find which of these 25 million reference files so they can slap the "do you want to buy it" on that thing. They have made, they meaning YouTube, we have made hundreds of millions of dollars for our partners using this content ID system, which takes your file, like we did with SoundHound, except now they have the file so it's not so noisy. Go through it, find what music that is or video, and do it. So my question for you is, as a group, what does this mean to you? First, what does it mean that they scan 400 years of video every day? Have they compressed time? And what does this mean, 25 million reference files in the database? So you have another 30 seconds with your friends. I want to know, what does 25 million reference files mean? And what does that mean, 400 years of video every day? What kind of sense can you make out of that? Discuss. Or discuss. Question. Which one of these do you right now, as a couple or a pair, are you having an easier time with?
400 years.
400 years?
Yeah.
It's interesting to me. That's almost always what happens. You go, oh yeah, I can figure that out. That's like, well, this is how many seconds there are in 400 years, and I can figure out that that's this many seconds of video, and they upload it, they just rip through it or something like that. You kind of equate a 1-minute video is this amount of stuff, and this how many is uploaded all the time. I don't know what explanations you've come up with in a full class when we weren't doing the just take it out of the oven fully baked Julia Child mode. We'd get you all to contribute what you thought and what your reasonings were, and we'd come together on kind of some kind of consensus-driven approach. What is the 25 million reference files? Does anyone have any questions about that?
Yeah.
Go, Jeff. You're going to tell me something.
I'm curious if my idea is right on it. Is that okay?
Yeah, absolutely.
That there's some sort of analog to digital representation of the song, so maybe a wave turned into some sort of, the reference file being the wave drawn out digitally, and then the scan being taking the sound from that video and creating a visual representation of that wave, and then comparing it to 25 million in the reference database to see if it shows up or if there's a certain threshold if it matches something.
Did everybody get that kind of general idea? That is absolutely the essence of what's going on, and you can read more about this. I'm going to kind of condense this into showing you where you can find out about it. So there are Music Brains and AcousticID.org are some open source versions of this audio fingerprint. That's kind of what you were describing, that you take in our room with SoundHound, that was absolutely analog, because it was taking the waves in the room, and when you upload it to YouTube, it's got a digital version. So it doesn't have to like play it with a microphone there, but it's just going to like analyze it immediately electronically and do some, in some cases, and it's fascinating if you understand those things. It turns out I don't really understand fast Fourier transforms, and I don't understand finite state transducers, but there are these competing technologies for how you do fast. So the key is you have to generate the ID. That's the audio fingerprint. How do you generate that quickly? We saw that with SoundHound. YouTube has to do it to do 400 million years of work every day. You have to do that fast. So you have to be able to generate that ID, and then you're right, so these reference files are these IDs. But you can't have kind of one ID for the whole song, because it doesn't matter what snippet of song you play. Right? You can play the middle, the beginning, the end. You can actually take something like Audacity, take the song, change aspects of it to make it more drawn out or higher or lower, and it will still find it. It's unbelievably kind of resilient to noise in some ways. So how does it has to do this fast and this fast, and that fast, that's search. Last time I checked, that's search. This part is the search, looking it up. But you know what? For those of you that know about hashing, once you've turned it into a numeric ID, finding it pretty easy. But that process in general is something that we can talk about in these different courses. The key features, what are the key features? In the longer version of this, we could talk about what those key features of looking up that song are. Both the version that you did on your phones and the version that cuts up to YouTube. It turns out, and I gave you those references to see how it works, if you want to delve more deeply into it. The Digital Millennium Copyright Act is, in this version of the course that I teach, we spend some time talking about the laws that are affecting technology. And about 7 years ago, people were, and then before that, Digital Millennium Copyright Act was 1998. So for 10 plus years, people were like, oh, this is crazy, it's killing innovation everywhere, because it was illegal to do things like unprotect your DVDs that came protected. In the old days, you downloaded something from iTunes and you couldn't play it anywhere else except one place. Now it's mostly doesn't have digital rights management on it. And YouTube is indemnified by copyright people suing it. By having this stuff taken down, you can't sue YouTube for posting copyrighted materials. They do host copyrighted materials, there's just no question. But they get this safe harbor that says, as long as you're willing to take it down, you cannot come after us for money. Now, that's because YouTube has some other stuff going on, and there's a whole discussion you can have there about why, for example, Kim.com. Anybody know who Kim.com is?
Yes.
Where did he used to live?
Australia.
Yeah, it's like New Zealand.
New Zealand.
And he owned a site that was allowed you to download things, mega upload, that you shouldn't have been downloading. It was because you didn't have the copyright on. And they caught up with him for that and somehow put him in jail in New Zealand for breaking, I don't really understand it. In computer science principles, there is an explore impact performance task. There are aspects of what we just went through, the content ID, that you could absolutely do there. It turns out that taking a lot of stuff and converting it into a fingerprint, take a whole file or a whole audio thing and converting it into a single string. Some of you may have seen SHA-1 or MD5s. You download a whole piece of software and they say this is the hash of that software so that you can identify whether you downloaded something that was fake or not. And you can do that in like 6 lines of Java code. So by taking a big file, it takes just a second to turn it into a single number. It's like a 120-bit number, it's a big number. And then if you go into, say, an image and alter 1 pixel by taking the red value and changing it by 1, and then you run that through, you get a different hash. Because you want to be able to tell that these are different, which is related to, and interestingly different from, the audio fingerprint, where if you want to go through and change a little bit in that audio file, you still want it to come out the same. Because that's trying to identify noisy stuff. The SHA-1 wants to say, I put a virus in your software. It's a 1-bit virus. It still will be able to identify it by having that fingerprint. In exploring computer science, there is a final project there. I think there might be some room to do something with uploading educational content, seeing if it could be taken down. But since I haven't taught an exploring computer science course, I don't know. All right, I got 10 minutes to do the next part. Leave the room for questions. So, all web pages are important, and some pages are more important than others. This is a riff of a quote from a literary work. No, close. Animal Farm. Right, an Animal Farm, all animals are equal, but some are more equal than others. All web pages are important. Every web page in the world is important to whoever created that. Some pages are more important than others because when you do a search, you want the search to work. If you search for CSTA 2014, you don't want to wade through the 100,000 hits you're going to get to find this conference. And you're confident that when you use that Google query, for example, the top hit is probably going to be the web page for this conference. Has anybody ever used this Google query? At least one person besides me. If I type "what is a good way" into the Google search bar, this is what comes up. I found that a little interesting. Which of binary search and content ID makes Google find these beginning things more easily? That's a tough question. But if they all begin with the same prefix. And if you have to search through something, that's all the search queries that are going on right now. If they're ordered alphabetically, you can find all the ones that begin with the same prefix by using binary search. You can turn that into an interesting project. How does Google determine the order for the results? That's my question to you. CSTA 2014 is going to get, one of the top pages is this. If you need to find a foot doctor in St. Charles because you got some infection from the pool, and you need to find a good foot doctor, and you say foot doctor St. Charles, Illinois, you want that thing to come up to be a good one. How does Google determine the order for the results? This is like not a right or wrong, just have a discussion for 30 seconds with your partner. Go!
Okay, so it has search terms have to be yeah, just location.
not enough time. I know, I'm doing Julia Child, I'm baking that turkey so fast. Some of you remember Alta Vista.
Yes.
Back when the web was useless. But it wasn't, because it was like the first time you were trying to find something, so anything was better than nothing. The problem was that you didn't always get the best hits at the beginning. Let me ask you a question. Show of hands. You make a search, you use Google for search, and you don't see on the first page the thing you're looking for. Are you more likely to A, go to the next page, or B, make a new query? That first page is incredibly important. Being on that first page, especially if you're a business, unbelievably important, because people don't go often to the next pages. So, determining what comes up on that first page, incredibly important for, you put something on the internet, these days, mostly people don't find things by, what was that URL again? Sometimes they do. But invariably you end up, oh, I'll just find it again, I'll just Google it. And then you find it. How do you, and the way that's done in general is, I want to know if this web page is more important than this web page. The basic intuition behind how that works is, if the links to my page A, if those links are better links than the links for my page B, if it has more better links, it goes more better higher. If the links coming into this page are better links, higher quality links, not just more links, because more links you can fake, right? I can put 1 million web pages that all link to this page. It has to be like good links.
What's a quality link?
That's an excellent question. What's a good link? What's an uninformative, almost useless, but good answer?
The pages that link to it.
Something.
Yeah, so here, the answer is, if they come from good pages, they're better links. Well, how do you know they're better pages? Because the links to them come from better pages! And it turns out, if you set this whole thing up, in case you care, as a giant equation in a big 2D thing, it turns out that finding the good links, because they come from good pages, which are pages that have good links to them, which come from better pages, is this relatively simple eigenvalue problem. Relatively simple, except that you've got like 2 billion of these things, so the matrix is huge. So actually solving it is very tough. But that idea of important links is what differentiated Google from Alta Vista and the earlier search engines, which used to say things like, well, if the word tuna appears 1 million times on the page, maybe that's an important tuna page. And then you would have all these hidden texts in those pages where they would put words to make it just appear higher.
Was there a story recently, maybe in the past few months or more, that some company, a well-known company, got in a lot of trouble with Google? They got booted, I think, from the search results for manipulating?
It's very easy to try. Companies are often trying to manipulate their search results. I don't have time to do this exercise, but if you follow that link, you'll get to a JavaScript page that lets you play with some page ranking so that you can play with your students. But manipulating search results is key, and Google does change its search algorithms to try to do that. And here's a story that's a 10-minute story told in 2 minutes.
Oh, I know this.
Mugshotsonline.com and removemymug.com. There's an article in the New York Times this year in which it was determined you could find these services that would come after you. If you've been arrested, your mugshot's a public record. Companies would scour through all those mugshots, put them online, and then say, you know what, for a small fee, like $300, we'll take your photo down. Now, depending on how you think, here's a mugshot of a person. If you look at this thing down here that I've highlighted in red, what it says is, an arrest does not mean the individual has been convicted of the crime. Individuals on this website are innocent until proven guilty by a court of law. The information related to charges and arrest or booking is provided through public domain and in accordance with the Freedom of Information Act. Meanwhile, this person's face and their name, because the name is in there, this is Ryan James Baumhover from Chapel Hill, NC, my town. If you're arrested, you're put online. It does not mean you're guilty of anything other than having been pulled in. Now your mugshot's up there, and the article is about these kind of nefarious companies that charge money to take your mugshot down. When the article came out, here's what happened. Are they acting legally in putting those pictures up there? Is it ethical? We don't have time to engage in this long discussion. That's like a whole classroom discussion in my class where you get together and decide on the differences between legal and ethics. It turns out that what Google did, they changed their search algorithm to make those hits. Like when you put someone's name in, that's why it was in trouble. Because you put Owen Asherkin in, and my mugshot would come up at the front for something. Well, it wasn't me. It hasn't happened. But I could see how it might have happened just by mistake. So Google changed the search algorithms so that those sites that used to be high-quality sites with links to your name now are low-quality sites. So they changed their search algorithm just to do that. MasterCard and PayPal stopped allowing those websites to use their services to process fees. And that was a very quick way of taking them out of business. Is that legal and ethical? So there you go. There you go. There's one more story here. This link will take you to a guy who runs a website for designer eyeglasses. And this was 3 years ago in the New York Times. His website was the first one that you found. I want to buy Dolce & Gabbana glasses. I want to buy Ray-Ban Wayfarers. I want to buy these. You come up online and go to his website. You sent him your money, and he would not send you anything. Or he would send you something that was broken. And if you kept following up, he might come back with you eventually. But it was a painstaking process. So guess what happened all over the internet? Bad reviews. But bad reviews come from good sites. Those bad reviews were really from like reputable sites that people thought were high quality sites. So he was getting more links from good sites to his bad page. And they interviewed him in the New York Times and said, you know what, every time someone complains and posts it, I'm a happier man. Because my page rank is going higher. They're just going to keep finding me. So Google had to change their search algorithm, their page rank, to deal with that. Because they didn't want those good sites' links to be counted as good. So they had to kind of go in and tweak the system to make that not work. So what is the connection between these three different kinds of search? We did binary search, we did content ID, and we did page rank, and I didn't really give you a whole lot on page rank. There's a lot more to do there. In that link that I left there, you can find more on how it works from a mathematical standpoint. I never actually do that. It's too complicated for me. That means that I have some students for whom it wouldn't be too complicated. They can go off and do that on their own. And the common themes from your definition of computer science. So at this point, if I had the ability to go do that fully baked Julia Child thing, we'd come up with your definitions of computer science that you all had entered into your Google form. We'd look and see, can we pull out from any of those the themes? Now, I heard some words. I was kind of listening as you were coming up. There was like programming and impact and some other words. And I think if you go back and think about those, did some of those apply to these three algorithms that we just looked at? A little, maybe. And if you think about how that works, I think I have one more slide. You could, what's in common across these courses and these types of search? So you could come up on your own with something here, something here, something here. But because I want to leave you at least 3 minutes for questions, I'll tell you that for me, instead of getting from you, this is the one thing I'm giving you. I haven't given you anything else today. Why do we need good search? Like, when is linear search fine? Like, I search through an array, I just look at every single element. That's a pretty good search. When does it stop working? When it's too large. Is it fast to search through a list of 2 billion things with a programming language like Java? Does it take more than a second to search through 2 billion things? It doesn't. So, when there's more than 2 billion, or when you're doing like a million 2 billion element searches. If you're doing a lot of searches, that scale is important. That content ID, looking at 400 years of video every 25 million, scale is important. So the size and search and trying to understand those differences, that's important. All right, questions? Dazed and confused. Yes.
How long do you spend on each kind of, how long could you spend on each kind of search in a computer?
Almost all these searches for me are more than a day. Like, there's no way I do that binary search. I do a whole activity where we're trying to get at it so that the students can build their understanding. With you all, I figured you all know these things, so I'm not going to have you develop it from scratch. But for binary search, I want the students to build that up and understand really the difference between 1,000,000 and 20. Like, I want them to experience that and then build an understanding. So and then we do some more stuff. That's probably a 2-day activity for sure. Content ID, I mean, they all go over and do this project of create this educational video and upload it to YouTube, so that's a many-day thing. That's probably a day to discuss it, and then we have an assignment on it. And PageRank, I'm still unrolling that. I haven't figured that out exactly how I'm going to do, but that discussion, we do that discussion about legal and ethics in my computer science principles class. So there, it turns out to be an impact thing, and then discuss how society is discussing this from a legal and ethical standpoint. But it's at least a day for everyone.
In a sense, SEO is exactly what we're talking about, right? So there's a whole entire
Yes, business of search engine optimization. It's like there. That's what. That absolutely huge thing. Absolutely. Yeah.
Can you put back on the first slide with the URL?
Yeah. And of course, if you can't find it, you can always send me an email. That's where this presentation is. I will try to remember to link to it from my homepage. If you can't remember to write that down.
This is more of a comment than a question, but I love that you assign your college students making an assignment with educational content where it could be complete BS and that's okay. The content of the content.
Yeah, and it turns out that's the freedom of computer science principles has given me. Because if I tried to do that in my programming course, they don't get the same freedom. They think, oh, it's supposed to be something real. Whereas the other kids like, really? Content? Okay. And they have their idea of content runs the gamut. I had a great one, if I showed you the video, of some football players pretending that they were hitting internet packets that were tennis balls. And all the tennis balls had missing. Pretty interesting. That's a good one. Any other questions? Well, I'm around for at least another couple hours if you want to corral me. But thank you for coming and participating.
Thanks, Owen.